Alright, so in this video, we're going to take a look at the algorithm behind extraction of words from a string. So this is the string that we are dealing with. Foxes are cunning. Now, if you are asked to tell what are the index ranges where the words occur, then what should your answer be? So the first word that we have is foxes, right? So foxes has a start index of 0 and it has an end index of 5, a stop index of 5. Now, why am I writing stop index as 5? Because these are the indexes that are required to extract the word foxes from the string str using the substring library method. All right. So similarly, this is a challenge for you. Find out what are the start and stop indexes for the following words so as to use the substring to extract them from the string str. Take your time, pause this video and see if you can come up with the right solution. So what I'm asking is to write the start and the stop indexes of these words from the string str. All right. Okay. So here are the answers. Now R starts from 6 and its stop index would be 9 because substring goes from start to stop index -1. So the start and stop index for R is 6 and 9. All right. Now similarly for cunning, cunning starts at 10 and the stop index for this would be 17. All right. Now there are a few observations that you can make from the word index ranges. Now, what is that? You see, have a look at the first word. Now the first word always starts from the index 0. All right. So if the string is free of any leading spaces, then the first word will always have the first index as 0. All right. Moreover, look at the spaces now. So every time we have a space, there are some words that are to its left and some words that are to its right. Okay. So these are the two observations that we have made. The first word begins at index 0 and whenever we get a space, there will be a word to its left and a word to its right. Okay. Now, from the second observation that we have made, can you tell me how can we get, knowing the space index, how can we get the index, the stop index for the left word and the start index for the right word? So for example, here the space index for this particular space is 5. So for this word, the left word ends at the index 4, isn't it? Left word at the index 4. So when space index is 4, the left word, it's 5, the left word ends at index 4. All right. And when the left space index is 9, then the left word ends at the index 8. Now, from this, can you notice a pattern? So what if the space index is S? Then how do we get the index of the left word? So if you notice this, when the space index is 5, the left word index is 4. When the space index is 9, then the left word ends at index 8. Similarly, when the space index is S, the left word index would be S minus 1. Therefore, whenever we get a space index, then space index -1 is where the left word ends. So that is our general answer. Space index -1. Now, let us try to find another thing. So, what is the index from where the right word begins? So, when the space index is 5, the right word begins from index 6. Let me use a different color. And when the space index is 9, the right word begins from the index 10. Similarly, if we have the space index as S, what do you think the index from where the right word begins would be. Notice the pattern. When the space index is 5, the right word starts at index 6. When the space index is 9, the right word starts at index 10. So there's an increment of 1. Therefore, when the space index is S in general, then the right word would start from index S plus 1. Therefore, when the space index is this, then the right word would start from index space index plus 1. I hope you have understood what I've tried to demonstrate here. Let's go through it one second. So given a space index, your objective was to find out the index where the left word ends and where the right word begins. So in general, we have found that whenever we have a spaces index, then the left word would end at space index -1 and the right word would begin at space index +1. So this observation would be required shortly in the next slide. All right. Now remember this, the primary objective of the word extraction algorithm is to find out the indexes of the spaces and then from there figure out what the ending index of the left word would be and what the starting index for the right word would be. So if you can get this clear, then the next things would be clearer to you. All right. So this slide highlights that point that I just said, that the objective of this particular extraction problem is to identify the space index first, and then from there figure out the left words, the index where the left word ends, index where the left word ends, and the index where the right word starts. So in general, if the space index is S, then the left word ends at the index S -1 and the right word begins from the index S +1. All right. Now let us look at a dry run of extraction of words. All right. So here in our Trident table, we have a few variables: I, star index, space index. Now, what does I refer to? I refer to the current position. So whenever we are extracting words, we would always start extraction from the first letter, isn't it? Therefore, the index from where the extraction starts is 0, and I would have a value of 0 at the very beginning. Now, start index refers to the index of the word, of the starting index of a word. Now, initially, while extracting the first word, the starting index would be 0, isn't it? The starting word, or the initial word, always begins from index 0. All right, and space index indicates the index where a space has been found. All right. Now, initially, as the space is not found, I'm going to initialize it as -1. I'm going to talk about this a little bit later. So what did I discuss just now? That our primary objective of this algorithm is to find out these index of the spaces. So I would be incremented to 1, start index would still remain 0, and the current index, the current character is in the space, right? So this was continue, and this would go on continuing until we arrive at a character which is a space, right? So 5, index 5 is a space. So the space index would be 5 now. Now, if I were to extract the first word, what would be the start and the stop indices of this word? 0 and 5. Remember how substring works. It starts extracting characters from the start index and goes up till stop index -1. So therefore, the word that has been extracted is foxes. Now, what is the index from where the second word starts? Well, that's 6, ain't it? And how do we arrive at 6? From space index +1. So therefore, the starting index will be set to the current space index +1. This is the index from where the right word begins. Okay? So this will be 5 + 1, 6. Now, similarly, I would again be incremented until a space character is found. And when a space character is found, I is at the index 9, the start index is still 6, and the space index is 9. Now, from where should I extract the word? What are the start and the stop indexes? Well, that's 6 and 9, isn't it? And therefore, the word R is extracted. Now, do you notice a problem? Now, if we continue on to find a space, we would not get a space, isn't it? When are we extracting a word? Whenever we are getting a space? Now think about this. Whenever we have an index of the space, for example here, the space index currently is 9. So whenever we have a space index, we can tell for sure what the left word's ending index would be and what the right word's starting index would be. But there's no way to tell the right word's ending index. So to get the right word's ending index, what you needed to do was, so let's take an example of the extraction of the word R. So here the space index was 5. I'm just going to write it as SI. So space index is 5. Now from this space index, it's clear that the word foxes ends at the index 4, and the word R starts from the index 6. But we don't yet know where the word R ends. So for that, we need to search for a space. And when we arrive at a space, then only can we tell that R ends at the index 8. So therefore, we require a space to extract the words. Now, you see, for every word, there is a space after it. For the first word, there is a space after it. For the second word, there is a space after it. Only for the last word, there's no spaces. Therefore, what usually is done is whenever we are working with a string, a space is appended at the very end of the string. So, at the very end of the string, another space would be appended. And the last index would be 17. And then the algorithm would continue on in its search for a space. And when it finally gets a space, then it can extract the last word. All right? Okay. So I hope you have understood this. Like, just keep it in your mind that in this algorithm, we are searching for a space. Whenever we get a space, we can extract the word that's towards the left of it. And from the space index, we can find out what index the right word starts from. And to extract the right word, we need to go to a space that's after that word. So every word has a space after it, and therefore for this space, this word is extracted. For this space, this word is extracted, and for this space, another space has to be appended to the very end so as to extract the last word. All right. Let's look at the algorithm. Okay. So in our algorithm, we have a few variables that we need to take heed of. I guess I overstepped. All right. Okay. So the algorithm consists of a few variables. Now, str represents the string from which we extract our word. Start index represents the index from where the first word begins, or for that matter, for any word begins. So initially, for extracting the first word, we need to start extracting from the 0th index. Therefore, we initialize start index with 0. Now, at the very beginning, we don't know what our space indexes are. Therefore, we initialize it with the value -1. Now, have a look at this particular line. Now, what are we exactly doing? Now, you see, our program is dependent on the spaces. The spaces define the ending of a word. And through the help of spaces, we are extracting the words. Therefore, any stray spaces in the string will lead to an abnormal execution of the algorithm. Therefore, what we are doing is we are trimming this a string of any stray spaces, any leading or trailing spaces. And then we are appending another white space at its very end to extract the last word. Now, only after appending the white space are we calculating the length of the string, because adding the white space would increase its length by 1, right? Therefore, if you calculate the length before this operation, then it would give you an invalid length. All right. Therefore, we're calculating the length of the string after the white space has been appended. And now for extraction, we are searching for a space within the string. Therefore, we are running a loop from 0 to length minus 1. That is the valid index strings. And then we check every character. This condition is used to check if the current character is a space. Now, if a space has been found, then only we can extract our word. So if a space is found, then I represents the index where the space is found. Therefore, we are storing it in a variable called space index. And to extract our word, we start extracting from the start index and we go up till space index minus 1. But we write space index over here because of how the str.substring function works. Now, after extracting the word, we must reset our start index, because you see the next word would begin from space index plus 1. Isn't it? The right word always begins from space index plus 1. That is what we are doing here. And between these two statements lies our code. So we may display the word, or we may reverse the string word by word. So any code that you want to perform with the word extracted will go between these two lines. But for the purpose of this algorithm, we are just going to display the word line by line. So I guess you've understood this at least briefly. I guess, I hope so. And if you haven't, go through this one more time. But I assure you, when you go through the program next, it will be much clearer to you, because I'll be using a few other examples, a few more examples to make this clear. All right. So if you have any doubts, go through this again, ask your comments. I'll definitely reply to them. All right. So see you in the next video. Bye for now.